All right, last little practice video, we're going to do some more sampling distributions of proportions. So let's say that we're looking at some kind of seeds. We're going to grow a garden or something like that, or just grow something. And this packet says that the germination rate is 92%. So about 92% of these are actually going to grow. Pretty sure that's what that means. So in this packet, there's about 160 seeds. Right off the bat, let's interpret some of this information. Categorical data. Does it grow? Does it not grow? Categorical data. The proportion of all of them, the population proportion should be about 92%. P is 0.92. We could even stop right now and immediately say we know what Q is. October, don't you start stepping on my tablet. Q would be 0.08. It's 1 minus P. All right. And there's about 160 seeds. Good, she didn't step on it. There's about 160 seeds. So what is that? That's our N. So kind of parsing this data as we're reading it can be useful. Part A, discuss each of the conditions required to use a sampling distribution for the proportion of seeds that will germinate. Okay, so we needed independence. Let's say hypothetically you didn't remember that. Where would you go? Properties for sampling distributions of proportions, which is this one. Okay, and that gives you all the data you need to know, all the information you need to know. So it's independent. Well, let's see. Is this bag of seeds less than 10% of the population? Yeah. Right? There should be at least 10 bags of these. So yes, 160 seeds is less than 10% of the population of all seeds. Less than 10% of the population of all seeds of this type. We have independence. Randomization. I can't spell today. Randomization. Did they randomly select the seeds for this packet? I don't know the production process. We're just going to assume that's good enough. And finally, sample size. Okay. The success and the failure condition. Do we have at least 10 expected successes and at least 10 suspected failures? This one's not so clear cut. 92% of 160 should be at least 10. Right? What is this? 92% of 160. That's not a percent, Jason. Nice try. Is 147.2. We have 147.2 expected successes. And you could multiply N times Q to find the expected number of failures. Or you could just subtract from 160. But I'll show you. Right? This is Q times N, 12.8. So we barely have enough for this condition. There's on average 13 seeds that don't grow here. If this was under 10, we could not model this. Again, it's kind of a rule of thumb, but it's kind of getting a little hairy. Okay. It's kind of getting a little questionable, but yes, we do pass the success failure condition here. Okay. So we have all of these. We can use the normal model. Kind of barely. So define this sampling distribution model and its parameters. Again, let P hat be the proportion of seeds that grow from this packet. This specific packet. This is a random variable. We don't know how many seeds are going to grow. We know on average how many are going to grow. 92% of 160. But we don't know, right? It's a mixed bag. I don't even know if it's the correct application of that phrase, but I tried to make it a pun. And we're told that the sampling distribution, p hat, is normally distributed with mean p and standard error square root of pq over n. So we just have to calculate these and we're going to be good to go. P hat is normally distributed. P, that's a proportion 92%. Square root of pq over n, I don't know what that is, but it's going to be 0.92 times 0.08 divided by n, which is 160. Type that into a calculator and fill in the blank. So again, square root of 0.92 times 0.08 divided by 160 is about 0.0214. And again, we could sketch and label the model, which is exactly what we're asked to do next. So this is our sampling distribution with this random variable on the left. Sketch and label the model. Again, I'm going to give myself more room this time. I never have enough room. Nice normal distribution. Here's the average. The average is 92%. One standard deviation is about at the inflection point, kind of where it from curves going one way to kind of curves going the other way. And that's going to be about 0.02 more than that. You can approximate a little bit. It's about 0.94. And then another sample standard deviation away is going to be about 0.96. And then another one, 0.98. And again, this is an approximation because the proportion can never be over 1, but the normal distribution goes on forever. But that's not a super big deal here. So this is going to be about 0.90 and then 0.88. And one more standard deviation is about 0.86. This is our distribution for p hat. What proportion of our seeds in our bag of 168 germinate? So what's the probability that more than 95%? Well, 95% is about here. What's the probability that this many? We could use the empirical rule and get an estimation. It's going to be pretty small, but not like minuscule. The probability that our p hat is more than 95%. Well, let's type the sampling distribution into GeoGebra. We can do that because it's a normal distribution. All right, so we go over to GeoGebra. All right, so normal distribution. The mean of this normal distribution is 92%. The standard deviation of this normal distribution is 0.0 something, 0.0214. And we're curious, what's the probability that our proportion is to the right of 95%? 8.05%. All right. 8.05%. Yes, that's totally what I was going to draw. Here we go. So it's pretty unlikely that we're going to get that many. We're expecting 92%. What's the probability that we get 95% out of 160 of these seeds? Not that likely. All right. This next question. Play some foreshadowing music. This next question is maybe the most important question for what's material coming up. Would it be unusual for only 140 or fewer to germinate? Would that be unusual? I don't know. It sounds like pretty good. Sounds like quite a few of them are germinating. But mathematically, let's answer this question. What's the probability that we planted all these seeds And on average, our proportion is less than, oh, what is that? 140 out of 160. What percentage, what proportion is that? Well, let's calculate it out. 140 divided by 160, that's 87.5%. Doesn't sound that bad. It's a probability that it's less than this. Well, graphically, we can look at it in green on the left. 87.5% is over here. Oh, it should be pretty rare. That's more than 2 standard deviations below the mean. Should be pretty rare. So, we approximate this. Less than 0.875. And we go into GeoGebra. Less than, left tail. 87.5%. Oh, that's pretty unlikely. Yeah. We could figure this out with the empirical rule. But our answer is about 1.77%. So it's actually quite unlikely to get something this bad. And 140 is still pretty good. 140 out of 160 seeds. Not too bad. But yeah, we're probably going to get quite a few. So visually, you can see this by drawing the model. 68% is within 1 standard deviation on average. About 95% is within 2 standard deviations. And about 99.7% is within 3 standard deviations of the mean. Okay? And that's it. Sampling distributions are really cool. Sometimes they can be confusing. So as you're working through these problems, don't hesitate to reach out if you have any questions. I love talking about this stuff. It's very powerful stuff. And it's really going to come into play in the next 2 units on confidence intervals and hypothesis testing, which are also very cool things. So stay tuned and good luck.